everyone, and welcome to NETSCOUT's presentation on assuring and securing AWS migrations with NETSCOUT visibility. My name is Michael Segal, and I'm the Area Vice President of Strategic Alliances here at NETSCOUT. And with me today, I have a distinguished guest from AWS, George Dean, Solutions Architect. The agenda that Josh and I are going to cover today is comprised of assuring and securing workload migration with NETSCOUT Smart Data. We look at best practices of utilizing the Smart Data for visibility throughout this migration process. Josh will then cover AWS and NETSCOUT together and detail the alliance that we have and the technology partnership. Then both Josh and I will cover technology, architecture, and specific use cases of implementing service assurance and security assurance best practices with NETSCOUT visibility. And last but not least, we'll hear some testimonials from our joint customers. So first, let me start with NETSCOUT overview. Uninterrupted connectivity is a key success criteria for corporations to thrive in today's connected world. And indeed, NETSCOUT's objective is to empower our customers to become the guardians of the connected world, to assure this uninterrupted connectivity. And we accomplish this by enabling our customers to establish visibility without borders. And you may ask, what borders are you referring to? We will explain which borders need to be transcended in order to accomplish this end-to-end visibility. And empowered with this visibility, our customers can now perform service assurance and security assurance. And our customers comprise the largest organizations in the world, including the top service providers, both public and commercial, large enterprises in a variety of market segments and verticals such as financials, healthcare, global enterprises, and many others. So next, let's take a look at best practices of assuring and securing workload migration with NETSCOUT Smart Data. First, I want to reference a study by IDC that looked at some visibility challenges in hybrid cloud adoption as they relate to the management strategies. And what they have uncovered is that lack of integration with the infrastructure and services, as well as they too operational concerns, are key challenges faced today by corporations. And by they too, what they mean is after the workloads migrated to the cloud in this case. So it becomes very clear that visibility for the operationalization of hybrid and multi-cloud is critical success criteria in today's hybrid cloud environment. And what Josh and I are going to cover today is the solution in terms of how NETSCOUT Smart Data is converted into actionable intelligence to support this level of visibility. And we'll discuss the technology alignment with AWS that empowers both NETSCOUT and AWS to serve our customers successfully. So let's take a look at some of the specific challenges associated with this visibility. For this example, I'm using a three-tier, pretty basic application comprised of presentation, application, database layers, and then some shared services, Active Directory, DNS, DHCP, and others. Initially, all the building blocks of this application are deployed in the data center, and obviously, for obvious reasons of economies of scale and elasticity associated with the public cloud, the customer now starts migrating workloads either via lift and shift or refactoring into microservices to the public cloud. Then the application can migrate to both the public cloud and the colo, and some workloads still remain on-prem. And database, same thing, some of the crown jewels may remain on-prem. So now what we see is a new hybrid environment that is more complex and more challenging to monitor, as well as increased attack surface across multiple components of the application, across multiple geographic locations, multiple technologies that are being used. And each one of this is a separate border. And what we need is to see everything end to end without any borders, across all these borders. And this is exactly what NETSCOUT means by visibility without borders. If we look at any kind of applications that we either use lift and shift or refactor to migrate, the next problem is identifying the root cause. Where exactly is the root cause of the problem? Next, you ask yourself, is this even a performance issue or is this a security concern? For example, is this like misconfigured load balancer and because of this, it doesn't scale? Or is this a denial of service attack? And the answer to this question would also imply ownership. Is this a NetOps? Is this a network issue? Is this a SecOps? Is this a denial of service attack, etc.? And then it all boils down because of the complexity and the increased attack surface. How quickly can you resolve the issues when things are constantly changing? You scale up and down. The elasticity is important. You migrate workloads back and forth. And then finally, the customer experience is critical, and you want to assure that there is improvement in performance compared to the baseline you established on-prem. Bottom line, visibility is really critical to empower IT organizations to execute their migration strategy successful. Let's take a look at it now from a journey perspective. And by journey, I mean the migration to the cloud journey. So it starts on day 0 pre-migration when you start the planning. On day 1, you actually migrate workloads. And on day 2, post-migration, after the workloads are migrated, you need to optimize performance. So like any business journey, before you start the journey, you need to understand your destination. You need to know where you are today and choose the right workloads to migrate. If the performance of a workload needs to be updated and fixed, then you first address the performance on-prem. Once the performance is optimized, you're ready now to migrate. You need to understand the dependency of these application workloads on service enablers such as DNS, DHCP, AAA servers, and others, as well as dependencies on databases and other components, because once you migrate, you need to migrate all the dependencies with the workload itself. You need to establish performance baseline, understand the user experience, and make sure that in the future, performance either meets or exceeds the expectations of your customers. And then now you're ready to develop the migration strategy. Now you have your itinerary, you have your meeting plan, and now you can embark on your journey. So now you're on a plane, you still want to assure performance, you want to make sure that your business objectives are not impacted during the transition. You arrived at the destination, now the business meetings start. You want to accomplish your objectives. And in this case, the objective of the application that was migrated is to optimize the performance as it compares to baseline, assure that service availability is maintained and user experience is supported and exceeds the original baseline benchmarks. And then you monitor vulnerabilities and security concerns across this entire domain. So what you need is end-to-end visibility or visibility without borders. And I mentioned some of those borders. You have now a very complex hybrid environment comprised of on-premises, public cloud, colos. You need to understand all the dependencies across all of them and understand them really not just from breadth perspective, but also depth perspective. It's layer 2 to layer 7. You need to understand the data link, the network transport session, presentation and application layers, and understand all the respective dependencies across all types of technologies, be it 5G, wireless, wireline, and any kind of application that is migrated to the cloud. So this is a pretty tall order. And what you have seen before is the dependency mapping from NETSCOUT that uses smart data to establish this actionable intelligence. But what exactly is smart data? How exactly does NETSCOUT do it? What's our magic? So it all starts with the packet data that provides ultra high definition, universally available information that is converted to smart data. So before we can actually produce smart data, we first need to acquire packet data efficiently. And this is what I call it's NETSCOUT's bread and butter. So in the data center, we have been acquiring packet data for many, many years. And you see some of the solutions available today, from integration with VMware, ESXi, NSX, NSXT that is extended to the cloud, including to AWS, any kind of hypervisor, including Hyper-V, OpenShift, KVM, and others, and using traditional mechanisms such as port mirroring on routers, spans, or physical taps or virtual taps. Now, in AWS, we partnered very closely with George Dean and the extended AWS team to also accomplish very comprehensive visibility or acquisition strategy, rather, of packets through Amazon VPC traffic mirroring and additional technologies on which both Josh and I will touch on. And then in terms of deployment, so the visibility is available from any virtual machine container or pods. So we are pretty much agnostic and can obtain the packets from any environment. And any kind of north-south or east-west traffic traversing the VPCs or within the VPC. So now that we acquired the packet data from key vantage points, we convert it into smart data. And for this purpose, we utilize the adaptive service intelligence technology and do deep packet inspection to convert the packet data into very sophisticated metadata with performance and security KPIs. And this technology is running on the NETSCOUT Virtual Stream appliance. Now, this smart data can be utilized, as we will demonstrate, by both NETSCOUT tools such as nGeniusONE for analytics on service assurance and Omnis Cyber Intelligence for analytics on security assurance. It can also be exported utilizing industry standards such as Kafka and REST APIs. It can be enriched with AWS-specific data such as VPC ID, such as MEID, instance, availability zone, region, and many others. And then it can be aggregated, analyzed, and visualized in a way that indicates the actionable intelligence that is required by the users using AWS native tools in this case. So let's look at the smart data adaptive service intelligence technology more in detail. What are the metrics that comprise this technology? So these are rich multidimensional metrics that include a variety of key performance indicators for servers, for network, for applications. It has session information, packet information. It stores packets in a smart fashion. Only relevant information for security assurance and service assurance is being stored, and the rest is being discarded. It has advanced metrics such as application response time, success and failure, and errors, because, as I mentioned before, heuristically we identify each and every application. So when we see the errors as part of the transactions, we understand the context of those errors. And then I also mentioned that we look at layers 2 through layer 7, so we can distinguish, for example, between network response time and application response time. And we do it per protocol, per message type, be it DNS, be it SIP, be it HTTP, or any other exchange. NETSCOUT also has unique expertise in both voice and video quality of experience metrics. Through the Site-Technics acquisition, we acquired very unique expertise in those areas. And here you see also some of the security metrics that are inherent to the adaptive service intelligence technologies. Because we see each action and transaction as security negotiation happens, we can understand if the ciphers are weak, if the protocols are weak. We understand if specific certificates have expired. Then we can look at the threat analysis and basically understand indicators of compromise. Last but not least, we look at behavior analysis, look at anomalies and deviation from baseline. So all this is NETSCOUT smart data that helps with smart application troubleshooting and monitoring and security. So now that we have the smart data, we can use it for actionable intelligence. So let's take a look at the few NETSCOUT native tools for actionable intelligence. And they're all derived from the smart data that I just presented to you. Some examples include the dashboard itself. So this is the 40,000 feet view of services, either based on geographic domain or IT domain. NetOps, SecOps can have their own views to establish common situational awareness. Once we want to investigate a specific service issue, we go to the next level, which is the service monitor, and drill down into load latency and errors associated with this. I mentioned before the dependency map. Again, layer 2 through layer 7 KPIs provided across all the dependencies of any workload that is comprising a service. We can then look at different applications that traverse a specific network or link. We can develop reporting that is customized, again, for a specific IT department, for example, or needs. It can be executive level, it can be technical level. Alerting, different alerts. Machine learning mechanism is utilized to identify anomalies from baselines that are established over time. And certificate monitor identifies certificates that have expired. The security threat is another actionable intelligence that looks, in this case, at indicators of compromise and alerts and provides workflows to resolve them and remediate the vulnerabilities associated with them. And last but not least, I mentioned smart packet storage capabilities, and this is utilized for both packet forensics as well as back-in-time analysis of performance and security risks. So we mentioned smart data. What is smart data? And now we see how this smart data is harnessed for actionable intelligence. Let's just summarize on how the solution is built. So on the left-hand side, you see the vStream on-premises will first start on-prem. And this is the virtual appliance. And you see also InfiniStream NG with the same functionality, but is a physical appliance. And you see two analytics tools. So these two appliances are probes that produce the smart data that we discussed. And then you see two analytics tools, the Omni Cyber Intelligence tool that provides analytics on the cybersecurity front, and then the nGeniusONE provides analytics and actionable intelligence on the service assurance front. In AWS specifically, we have taken the virtual appliances that I discussed before, and right now we see virtual nGeniusONE and vStream, and very soon we'll have the Omni Cyber Intelligence as well, part of the marketplace. We're targeting November delivery for this. And with this, we have the virtual appliances inside AWS, integrated into the AWS AMIs, Amazon Machine Images, and then also we're using CloudFormation template script to essentially streamline the deployment in AWS. And then on the right-hand side, I referenced several technologies associated with smart and effective packet acquisition in AWS. And you see some of these specific technologies which Josh will elaborate on, such as the VPC traffic mirroring, gateway load balancer, and NLB that is used actually as target to scale vStreams behind it. And Josh will cover all of that. So now that we understand what is smart data, we understand how it's being used for actionable intelligence, we understand the building blocks of the solution, now you can see how visibility without borders is being implemented. We deploy all these specific building blocks of our solution in any environment and achieve this end-to-end visibility without borders. I mentioned that this is a service level assurance visibility, layer 2 to layer 7. We look at the service and all the dependencies. Not just the application, not just the network, not just the database, not just the service enablers such as AAA, DHCP, DNS, and others, but also all their respective dependencies. We spoke about the robust security posture because now we have this extended security threat environment, and we can see everything, each transaction that is traversing this extended infrastructure, and identify key threats and vulnerabilities associated with it. And then also cross-domain network and application performance and others. So in order to illustrate the effective workflows of the nGeniusONE, which again, this is the platform that is responsible for the service assurance, let's take a look at the ASI again. So the ASI, the Adaptive Service Intelligence technology, is comprised from packets, which is the source of all the data. Then we have the session information. And again, because we can see layers 2 through layer 7, we can see basically the URLs, the DNS requests, login attempts, SIP information, SSL certificate. We then have conversation information, who is talking to whom and on what protocol, so we know how the information and transactions are exchanged, so we can analyze them. And then at the very top, we have the key performance and key security indicators for application errors, traffic volumes, mean opinion score can be attributed to different communities based on their IP address, on their quality of service, on their VLAN, and others. So with all this information available, we can now demonstrate how nGeniusONE is using this information to identify the root cause of any given problem within 3 clicks of a mouse. You start with the service dashboard, so you have a bird's eye view of all your services in the context you're interested in. As I mentioned, it can be geography, it can be IT-specific organizations such as NetOps, SecOps, it can be a specific application. So whatever way you want to slice and dice it, you can. And now you want to drill down and understand a specific performance issue that you can see on this dashboard. So you drill down, you do the performance analysis, and then you basically launch a service monitor that gives you the load latency and errors. And you can then understand which errors you want to investigate further. And you look at the session analysis, and those errors are derived through the transactions, right? We know who is talking to whom and what messages are exchanged. So you can do the session analysis. And last but not least, you can do the deep dive packet analysis to really understand the error code. And with this, within 3 clicks of a mouse, you identify the root cause analysis of any service degradation through visibility without borders, right? So we see it end to end across on-prem, cloud, colo, edge locations, etc. The second tool that I mentioned is Omnis Cyber Intelligence, and it has 3 specific modules. First, you see the security risks, and these are ASI, Adaptive Service Intelligence, specific risk, such as weak protocols, weak ciphers, expired certificates, and others. The second one is threat indicators, which basically identify any kind of anomalies and deviation from baselines. And last but not least is the cyber threat, which identifies indicators of compromise. It can be phishing, it can be malware or botnets, and you identify them. And what you see here, for example, dropper Trojan, adaptive persistent threat, you see backdoor, and you can immediately analyze it by looking at the hosts to which those specific IOCs are attributed and analyze the communication. You see red lines indicate that there is some kind of IOC traversing throughout the communication, and the width of the line indicates the amount of traffic that goes through this communication. And last but not least, again, the packet analysis. So this is the source of all our specific data, and we always go back to it. But obviously, analyzing packets without the context, without being surgically able to address only the relevant information, is mission impossible. So here, when we say packet, It's in the context of the specific information regarding the specific indicator of compromise and communication between the specific host and client. So that's what makes it so valuable. We were talking about the extended attack surface. So in order to mitigate it, NETSCOUT partnered with AWS and integrated its Omnis cyber intelligence into the AWS Security Hub. And as you all know, AWS Security Hub performs best security checks across the AWS infrastructure. And from that point of view, it collects the different alerts from a variety of other platforms, both AWS native and from partners, and prioritizes them and analyzes them. So what NETSCOUT has done is integrated its Omni Cyber Intelligence that is driven by ASI data and what is called Omnis Intrusion Detection Service from these alerts, and also driven by AIF, which is called Atlas Information Feed, which is based on an analysis of large portion of the global internet traffic to identify specific indicators of compromise. It exports alerts to Security Hub, and then from Security Hub, you can have contextual investigation drill down back to Omni Cyber Intelligence to really analyze the root cause of the challenge. And you can also utilize the data export through Kafka into a data lake for further analysis, as I've discussed before. So with this, Josh, I want to turn it over to you to cover AWS and NETSCOUT together.
That's great. Thank you, Michael. So as Michael's mentioned, AWS and NETSCOUT partner together in a lot of different areas. We've worked closely, NETSCOUT have worked closely with AWS on a multitude of different technologies. So just to take a look at a couple of examples of those technologies, one would be VPC traffic mirroring. This is the mechanism by which AWS provides packet data to NETSCOUT for analysis. It's a service part of the VPC portfolio. VPC ingress routing as well also allows you to bring inbound traffic from the internet or from a virtual private gateway to an appliance for inspection. Gateway load balancer, which is used for scaling out appliances. And as Michael mentioned so wonderfully, AWS Security Hub, which is a CSPM service that provides security best practice checks, aggregates alerts, enables the possibility of auto remediation. In addition to technological alignment, NETSCOUT work with AWS and are listed in the AWS marketplace in both commercial and GovCloud regions. And they also hold a couple of AWS competencies, which if you're not familiar with, the competency program is designed to identify, validate, promote AWS partners that have demonstrated technical and validated customer experiences. So within that field, NETSCOUT have achieved both networking and migration competencies. NETSCOUT also worked with AWS on the public sector side and are part of the public sector program. So AWS does have some native visibility tools that provide kind of infrastructure and log visibility through CloudWatch, network flow data through VPC flow logs, application tracing through X-Ray, and security alerting and visibility through Security Hub, which we've mentioned a few times here. NETSCOUT enhances these offerings by consuming data from both AWS and on-premise networks, converting it to that smart data that Michael talked about, which is then analyzed through nGeniusONE or Omnis Cyber Intelligence. The result there, though, is a comprehensive end-to-end performance monitoring solution and security solution, giving customers that AWS customers and NETSCOUT customers that confidence needed to kind of go ahead with migrations to AWS. So to demonstrate the technological alignment that we have, let's take a quick look at what a typical NetScout deployment looks like as it would be deployed in AWS. So as you can see here, first of all, we have a fairly common architecture based on both on-premise and AWS environments. Each are connected to each other through a variety of different technologies, be that internet connections, WANs, SD-WANs, direct connects, VPNs, so on. So if we start with the on-premise side of things, you'll see that we're using a variety of different technologies, some legacy or more traditional networking functions such as spans and taps to get data over to vStreams. From there, that data can also be then analyzed locally through the nGeniusONE or Omnis Cyber Intelligence platforms that we've talked about here. Within AWS, though, we also have those virtualized vStreams, which are just a virtualized version of the same platform running on an EC2 instance. And using AWS's VPC traffic mirroring, we can retrieve packet data from applications, forward it to vStream, which can then be analyzed through those same tools, nGeniusONE and Omnis Cyber Intelligence. In addition, so with VPC traffic mirroring, you can either direct traffic to a single vStream instance, or we've worked with NetScout to integrate with Network Load Balancer in order to scale out vStreams so that you can get the performance that you need. In addition, you'll see here a common architecture that customers are using Gateway Load Balancer and appliances for sort of IPS, IDS, firewall type use cases. NetScout has done some incredible work there and have the ability and understanding to decapsulate the Geneve protocol, which is what Gateway Load Balancer uses to talk to backends there. So they can actually see all the packet data coming from your Gateway Load Balancer to the appliances, in addition to all the application data that we already talked about. So using this data from both on-prem and AWS, you could utilize the same analysis platforms there. There's also integration then out with third-party SIEMs, such as Splunk and so on. And kind of a two-way integration with AWS Security Hub. So at its root, with all this data, NetScout pushes what we would call findings to Security Hub. These findings are security findings. Michael discussed those in detail, so I won't go into exactly what those are. But from there, there's a click back as part of the finding, which I think Michael will demonstrate in a little while. That shows you exactly how, exactly which event you're looking at, and you can drill down through those various layers into the packet data to identify. Okay, so we've discussed it some, but yeah. So NetScout and AWS have collaborated extensively, right, on both existing services such as AWS Security Hub, and as well new features and releases in the beta phase. Things like Gateway Load Balancer, ingress routing, traffic mirroring that we've talked about, and the list goes on with new technologies as well. I will say as well, just personally, I've collaborated closely with NetScout on the Security Hub integration, just to name one. I work closely with Michael and the engineering teams there to build the solution, validate the solution, test the solution, and even deliver webinars to our customers to show the joint value that we have. So you can see that we're really working in synergy to make sure we get these things right and that we provide the most value to our customers. And I was able to identify in my own account that how quickly you can identify and resolve these security related issues. So just to summarize kind of how AWS work and NETSCOUT work together, there are really three primary areas. First of all, technology alignment. That's what we spent most of our time talking about. But even existing NETSCOUT technologies can be seamlessly extended into AWS. So those legacy or on-premise applications, they can be brought into AWS. The same technology that you're using with NETSCOUT can be brought into AWS. NETSCOUT also helps customers migrate to AWS quickly and confidently by providing that monitoring and assurance of the applications kind of every step of the process. And then one thing that's kind of overlooked, NETSCOUT helps those IT teams that utilize AWS have a lot more confidence in their solutions and in their applications because they have that visibility and can monitor performance, improve performance of both applications on-prem and in AWS. So with that, I'm going to hand it back to Michael here for the next section.
Yes, thank you, George, so much to you, Harnish Patel, and others at AWS for your amazing collaboration and support. Really appreciate it here at NETSCOUT. So next, let's take a quick look at the nGeniusONE demo. So what you see here is nGeniusONE hybrid cloud dashboard. And I said before, you start with the 40,000-foot level, looking at the services dashboards. And I also mentioned that you can customize those dashboards to be relevant for the specific IT teams, such as NetOps, DevOps, SecOps, and others. And you can also associate them with specific domains, such as AWS, data center colocation. So you can slice and dice this specific service dashboard based on the corporate needs. So in this specific example, we see an AWS hybrid DevOps dashboard that identifies some errors in the database, MySQL database in this case. So then we go and we drill down from the services dashboard to the KPI flows. And this is the service dashboards that look at the specific database MySQL, looks at all the different servers that support it. And once we highlight one of the servers, we can then drill down and understand the performance over time and the errors over time. And we see that at a specific time, there is excessive number of errors associated with denied access. And the access that is denied is this specific MySQL database. So we really want to understand the root cause of the problem, and that was our first click, and we already see the type of error that generated it. Then we go and drill down into the session level, which is one extra click, and then we see in context all the different exchanges between the requests and responses associated with this specific MySQL request, and eventually you see an error associated with the SQL query. So then we drill down into the packet level, and here I'm zooming in into the packet, and you see now, this is the third click of the mouse, you see now the real root cause, which is error message associated with select command denied to enter root specific IP address for table employees. So basically, you realize whoever is trying to access this table did not have the right permission. And this is done end-to-end and in just within 3 clicks of a mouse. The other thing that I want to highlight here is that you see the encapsulation. So the VPC traffic mirroring, which is the fashion in which this specific packet was acquired, is using the VXLAN encapsulation. So you see basically the original packet is encapsulated in VXLAN over UDP, over IP, over Ethernet. And then you see the original packet, which is the MySQL request, is inside the TCP IP over Ethernet packet. So we just demonstrated how with this top-down workflow approach, we can really understand the root cause of a problem across hybrid cloud environment and demonstrated the visibility without border basically in action, right? So there was no border. We didn't care about which application, where's the root cause, is it in the database, is it in the network, is it application related? We could tell exactly what's happening independent of the source of this root cause. Next, let's take a look at the security aspect of the actionable intelligence with the Omni Cyber Intelligence and AWS Security Hub integration. So both Josh and I mentioned the Security Hub and the importance of Security Hub to address the specific cyber threat risks in AWS. So here specifically what we look at is all the different alerts coming from NETSCOUT by type. And we identify one of those alerts that is high severity. And now we can understand exactly all the information related to this alert. And also we have the source URL, which is basically an URL to the Omni Cyber Intelligence that enables us, based on this URL, to drill down and get the information regarding the security risks that are associated with the different violations and the hosts that are impacted over time, what exactly violation happened and when. Now you want to understand what is the source of this violation in terms of the host analysis, who is the host communicating with, and again, within the next click of the mouse, you understand actually the source of the communication, the volume of the communication, and now you have all the information required to remediate this specific vulnerability. So with this, what we have demonstrated is the value of the smart data for visibility without borders to reduce the mean time to repair for specific service assurance and security threats. So let's now take a look what our customers are saying about NETSCOUT solutions in AWS. So the first customer provides a testimonial to the fact that traffic data at the source is the most effective method of assuring service delivery across any hybrid cloud. And indeed, what it implies is that traffic data, if utilized effectively, the way that NETSCOUT is converting it into the smart data, it is very effective in assuring the service delivery. Next, we were talking about quickly, within 3 clicks of a mouse, identifying the root cause. Once you're identifying the root cause, you would assume that mean time to resolution is being improved. And indeed, what you see here is Fidelity testimony saying, indeed, the mean time to resolution has been improved by 80% or greater with NETSCOUT proactive service triage, which is what nGeniusONE is doing. Another testimonial is talking about a superior customer experience. We all said, before you embark on your journey, establish the baseline, and then after the migration is done, assure that the same performance baseline and user experience is met or exceeded. And indeed, what you see here is that NETSCOUT smart data and actionable intelligence and visibility without borders are assuring a customer experience that is delightful and high quality. And last but not least, we said visibility without borders. We discussed the specific borders. And here you have another testimonial about the smart data technology enabling end-to-end network visibility platform in our enterprises' cloud and WAN environments has been instrumental in reducing troubleshooting times by over 90%. So any application that traverses across that network can now be effectively resolved, and the root cause analysis can be done very, very quickly and efficiently, and either the performance issue or the security threat remediated. So with that, Both Josh and I want to thank you for listening, and thank you so much.